last but not least, we have Jonah Boucher. I can let you fix that one in a minute. Who's the lead curriculum designer for BlocksCAD. So come on up.
Hi, great to be here today. Jonah Boucher, so close. The French is tough. I'm a high school teacher in the Boston area, and one of the things that I use in my classroom is BlocksCAD, and I also do professional development with that tool. So I'll be sharing a bit today from the educator's perspective and the curricular designer's perspective. Here with us today is also BlocksCAD founder and CEO Saul. So any tricky technical Blockly questions will be headed his way. Yeah, thank you for having us. So I'll talk a little bit about the building experience in BlocksCAD, what students do on our platform, and kind of where it came from. Then about the curriculum and teaching and how we've built a support system around the tool to really let it work in standards line classrooms in public schools primarily. And then talk about some of the extensions and applications that we see our teachers using. So BlocksCAD's origin story is really in the makerspace world, where Saul and his co-founder Jenny were running a makerspace and wanted more curriculum-aligned ways for students to be interacting with things like 3D printers and the CAD design process. So I'll show you what came out of that. So on one hand, there's the tool, which is BlocksCAD. It's a cloud-based, project-saving, web-based, so we'll have students using it on Chromebooks and iPads. They can access at home just as well as they can from their classrooms with their teachers. And as we often hear teachers exclaim, it is the familiar Blockly interface. I was just on a call earlier today. We're like, is that Scratch? And they're thrilled to know that their students are familiar with the interface. On the curriculum side of things, what we've built around that tool, we operate primarily in the 3rd through high school space, with kind of the sweet spot being 5th through 8th grade, right when students are starting to interact with CAD programs and language-based programs. We have teacher and student-facing Common Core, Next Gen, standards alignment across computer science, math, career and technical education, and many teachers themselves have done engineering alignment for us and other emerging standards. So to take a look at it, we primarily start students off with understanding 4 geometric primitive shapes, and they interact with those using transformations. So I'll have 3rd graders who are speaking about 3-dimensional transformations, which is 5 years ahead of where they need to be mathematically. And that's really what we've tried to do, is overlay a rich mathematical experience on top of the fun building experience that students already have in other types of platforms. So you can see here with something like even building a tree, this is non-trivial for young students, and even for older students, it makes connections they might not otherwise get in a text-based math environment. So something like making a cone requires changing the radii to be unlocked, so that instead of making a cylinder, we can keep the bottom radius and the top radius different, and students get this connection between what a cone is and what a cylinder is. So those are the insights that I use our tools to try and pull out of students while giving them this visual environment. So much of the math classroom and math standards these days are asking students to do things in their head that they could much easier visualize, and we're trying to take that into the building process so that students can see what's happening. So as you can see, these blocks are overlaying OpenSCAD code. We only have students interacting with the blocks. There's just a little toggle in the corner where they can see the code. So for many students, this is the first opportunity they have to realize that what they're doing is programming, and often use that just to show students what they've actually built, even if all they need to understand is interfacing with the blocks themselves. We typically start students off with pretty simple projects. The snowman, the caterpillar, and the robot are 3 of my favorites, because all we ask of students is, can you learn to translate basic shapes in 3 dimensions? From there, we explore all sorts of complexity. But even with these kind of projects, we see students exploring and differentiating on their own. One of them will discover the rotate block and learn that they can turn a cylinder on its side. One of them will figure out how to make the cone nose and rotate that. And pretty quickly, we have students making projects more like this. So to do designs like this, they're using set operations like intersections, differences, to have those 4 basic primitive shapes interact with one another. And that's another big thing we ask of our students is the complexity you see in the geometries of the world, how can we make that by just interacting simple shapes together? So we see quite a bit of fun emerge from students using that. So we've sort of been living in the top left corner so far, which is what students see. And that is really where BlocksCAD started. It was just a fun way for students to create objects, export to a 3D printer, or export the blocks and use them elsewhere. But what we've built over the last 5 years or so is really a support system around that. A classroom management program, lesson plans, 150 growing daily of lesson plans across standards, and then professional development experience. So I'll speak a little bit to that today too, because really what we see when we're engaging with district leaders or teachers is, yeah, this looks fun. I know my kids would love this. How can I get this past my admin? How can I get funding? So we've been doing quite a bit of that. So here's an example of a project that does this well. These are pizzas that some 9th grade geometry students of mine made. We align this in a few different ways. First, I'll use this. The school I was at did not have any computer science, so my students were coming in brand new to anything like loops. But we would use loops to add our toppings. So I'd have students translate and rotate the first couple of toppings. They'd get sick pretty quickly of the copy and pasting of the code, and we'd pause and wonder, what are we really repeating? All we're repeating is translation around, or rotation around the z-axis. Can we find a tool that can do that faster for us? So we explore the loop, we learn how to place a variable in the z-axis rotation, and all of a sudden, instead of copying and pasting code for a single topping, they can copy and paste instructions for how to make a topping, switching out which shapes they want to be iterated. So we'll get students talking about loops there. And it's perfect for my math classroom too. They'll see what 360 degrees means. They'll see what 180 degrees means when they change the parameters of their loop. Alternatively, we run this as a math lesson assigned to 7th grade standard. So I'll have students build simpler pizzas, usually at that age level, and then we'll ask some of your classic word problem questions of like, okay, you each made 2 different pizzas, calculate your areas and your circumferences. Or if you make 2 pizzas with a certain circumference and someone else makes another, who's got the bigger pizza? We'll ask questions like that where they've now built something, they've got this place to ground their mathematical understanding, and we'll tie it into the curriculum. You can see with some of the pizzas here, students explore randomness. So when they're running their loops for their toppings, they can randomly generate rotation, or they can randomly generate placement from the origin. So we're asking students to engage a little bit mathematically there with how they can get as realistic as possible with the tools we have. On the teaching side of things, we've got a back-end platform that allows a teacher to monitor student work. So we're looking at a classroom for an after-school program I've run. Each row is a different student. Their accounts are directly linked to mine as a teacher. So I can see timestamps on how long they've spent. I can see whether I've assigned them a project or whether it's something they worked on their own. And then I can go in and open their code, see exactly what they built. I can edit it directly, leave them comments, leave them grades. So this is where our educators are using a full learning management system to manage student work within this platform. I can also bulk download STL files from here if I want to send them to our makerspace or print them on the Maker materials that I have available. And finally, just to mention a few of the places that our educators are taking this tool. The 2 pictures on the left are an example of collaborative projects where students have individually built something, and then we've combined their code together by exporting the XML files. So we often have teachers facilitate this for younger students. Older students, we'll put them in a group. They'll learn how to share those XML files, and they'll import code into each other's projects and create something like an imaginary city, or that classroom was a quite detailed replica of the classroom I was teaching a group of 9th graders in. So we built that over the course of 2 days. And it's great because all we needed was 1 student to build 1 chair, and they figured out, all right, we can copy and paste, we can translate, we can scale, and they did a lot of that work to get everything working. We have partners in the AR and VR space as well, so we'll export the 3D files that students make. We've had some teachers bring them into animation studios and have students do animation work. We partner with ZSpace, so students can be doing virtual reality while building or interacting with what they've built after they've built it. And then, of course, 3D printing. We find that many schools these days have 3D printers gathering dust because they haven't found ways to pull them into core curriculum. And we've really been able to engage math teachers and computer science teachers in getting kids to the maker space to print what they've created. So that's BlocksCAD. I'd love to answer any of the curriculum or teacher end of things, and maybe Saul can chime in if we have any questions on the technical end, but thank you very much. Appreciate it.
Awesome, thank you. Well, that was our last presentation of the day. So any questions in the room for Jonah? I see Josh.
Yeah, super exciting. Love BlocksCAD. I'm curious, so the examples you gave around math, very cool. Are you seeing teachers being able to replace parts of their curriculum with this, or is this like a supplement that they're doing in addition to all the other things that they've taught?
Yeah, we don't see it as replacing like an entire math curriculum in the way that some of these other just like across the board math programs would. So we see it as plugging in for particular standards where it does better than other ones, particularly anything geometry or visual. We'll see teachers run like a week or week and a half BlocksCAD unit and then revisit it later in the year when they're now talking about transformations or something. So we don't want to make the pitch that it's on top of what they're teaching, but we also don't make the promise that you can replace your Algebra 1 curriculum with BlocksCAD.
Great, thanks.
Yeah.
Cool. Other questions in the room? Christopher?
So it looks like a major sort of selling point of this work is the LMS that's built into it. I'm just kind of curious, roughly in terms of engineering effort, what's the balance between front end, the part the students are using, and like the back end parts the teacher are using?
Saul, do you know close to that? I'm not positive.
From development
Yeah.
it was a lot of work to build the LMS, but right now pretty much stays on its own. We try to spend most of our time supporting, most of the time spent in the editor, students building, supporting that work, adding in. Jonah leads the team that adds curriculum, just trying to increase the experiences. But we're doing a little bit of tweaking to the LMS, but mostly focused on the building now.
Thanks.
Sure.
Great. Chris?
Yeah, hi. So just a question. There's a lot of vocabulary in your blocks, and you go as young as third grade, but what would you say your sweet spot is? Like what age is, because I can imagine some of those words being a little tough for a third grader.
Yeah, absolutely. We want to get them using it early, so I love that it's translate and not move, for example, as a math teacher. And I've seen third graders get that well. I think we pick it up fastest 5th grade and beyond. 8th grade is where we start to see students who want to be engaging with the text a little more than the blocks. So somewhere in that 5th to 8th is great. But really our bottleneck at the youngest ages is often just physical skills with the mouse rather than the vocabulary. Because there is that one-to-one correspondence, even a kid who doesn't know the word translate, when they change that number and they see something move, they'll start to understand what that block does. So yeah, that goes pretty well.
Thanks.
Great. Awesome. Okay, I'm not seeing any questions. Jason says that was a great question. Supporting the workflow around learning is a real thing. But yeah, no other questions here except for Neil in the room.
I would love to hear your thoughts on 2D versus 3D. Does 3D make things more difficult for students, or does the reward factor? Basically, I'd love to hear your thoughts on 2D versus 3D.
Right, so we have 2D blocks that you can use in there. I almost exclusively use 3D for our purposes because when we do need to be thinking in 2 dimensions, I'll just have students bring the z-axis down to something like 1. So it looks 2D. We do have some applications our educators will use where they want to be exporting those true 2D files for like bird's eye drafting kind of thing. But for the most part, I want the z-axis in my students' vocabulary as soon as possible, and because they're able to like toggle around the axes, they understand pretty quickly how that third dimension works. So yeah, we're there as often as we can be.
Hey, Jonah. Another question in the room. I'm just curious about how you all look at the data and like maybe from a reporting perspective and share it with the teachers of the back end, like all the data around like what students are doing? Do you do anything to kind of really help teachers analyze that data and use it?
Yeah, I think that's the next phase of our support. So we capture tons of data for them, and the one they use most often is just the time spent in project. And they use that as a proxy for engagement, but I think a growth area and a place we're pushing into as districts ask for it is to really better be able to understand like where are students getting stuck. We've done some partnerships that we've explored with like AI tutoring tools that could maybe overlay what we do so that when students are doing independent projects, they could get better hints that are playing off, here's where a student typically abandons a project is right when they're getting to this phase. So yeah, we're really excited about using all the rich data we get to support a teacher better, particularly asynchronously when their students are trying to use this from home.
Cool.
Great. We'll take another question in the room.
Yeah, so in the example of the tree, do students have more difficulty coming up with the idea of what type of shape they need to use? So like in that case, they use a cylinder, or is the more difficulty and they know they need to use a cylinder, but how to implement that into blocks? Where was the more difficulty based on your experience?
Yeah, I'd say it's the latter. They're often, and sometimes we'll scaffold this, so they'll do some sketching first, or they'll try and name to a partner what shapes they might want to use. It's the implementation where they struggle, and one early example that happens often, particularly with young students, is they'll be confused for a long time between the difference between changing the parameters of a block itself versus changing, say, the translation. So like rectangular prisms also have the XYZ parameters, and the translation you put around it has an XYZ parameter. So that's the kind of thing where they'll know what they want in their mind's eye, and they really have to get used to. And we practice having them say, are you trying to make your rectangular prism longer, or are you trying to move it along the axis? So it's that implementation step that is harder. Yeah.
I see. Thank you.
Awesome.
Great. Thank you all.
Thank you so much. Great. I do see one more question for actually a previous presenter. Carlos, would you mind going to that mic if you're able to answer this question that says, it's from Jason. Do I understand correctly that Jupyter Blockly will work for any Blockly language that targets a language for which there is a Jupyter kernel?
Yeah, if there is a kernel and there is a generator, like it will work. The only thing we do is so kernels have some metadata where you can see the language they have and some other information. The only thing we do is we compare the language name with one of the generators that we have already imported in the extension, and that's all. So it will work. Yeah.
Awesome. Thank you. Then I'll pass it to Rachel to close us out. Those were all the presentations for the day.
Yeah. So this is the end of day one. Thank you everyone who gave presentations in this room, everyone remotely who gave presentations as well. There's a lot of really exciting stuff here, and that's actually my favorite part of the summit, is getting to see all the cool things that people have made that everyone is keeping in their back pocket, never mentions, and then they show up and they're like, oh yeah, I did this, by the way. I'm like, you can't do that. So this is day one. We have day two. Day two is tomorrow. We're going to start at 10 a.m. Eastern for the actual start of the talks and the summit part, but we will, as we did today, have food out there starting at 9 a.m. Eastern, and you're welcome to show up early. Come on in, hang out, talk then. So we'll see you around.